Now that we've learned to solve exponential and log equations, we can revisit some of the applications that we've looked at in this chapter and start answering more complicated questions. So, our next example, suppose that we inherit $25,000 and we want to know how long it will take for it to grow to $500,000 if it is invested at an interest rate of 5.75% compounded monthly. Okay, so we have a principal of $25,000. We have an interest rate of 5.75%. We have a compounded monthly, so n equals 12. We have a future amount of $500,000, and we want to know how long will this take. So putting this into our compound interest formula that we've worked with previously, we'll have 500,000 equals 25,000 times 1 plus the rate in decimal format, 0.0575, over n, which is 12, to the 12 times t power. So again, our compound interest formula that we worked with in section 4.1. Okay, so in order to solve this, we need to use our strategy to solve exponential equations because we have a variable that's contained within the exponent. So before we do much, let's go ahead and figure out what is 1 plus 0.0575 divided by 12. So if you do this on your calculator, you get 1.00479. to the 12t power. Okay, so that's our exponential. So solving an exponential equation, we want to get this alone. So let's divide by 25,000. 500,000 divided by 25,000 is 20. Okay, now that the exponential is alone, we can take the natural log on both sides. And then use our power property to bring 12t to the front. Okay, so in order to get t alone, we would need to divide by 12. And we'd also need to divide by the natural log of 1.00479. Okay, and now t is alone, and we'll need to divide the natural log of 20 by 12 and the natural log of 1.00479. So on your calculator, how I would do this is in 2 steps. So natural log of 20 divided by 12, enter, and then divided by the natural log of 1.00479. And we get 52.24 years. Okay, so about 52 1/4 years it would take $25,000 to become $500,000. Example 8, we revisit another type of application that we've seen previously. The percentage of adult height attained by a boy who is x years old can be modeled by f of x equals 29 plus 48.8 log of x plus 1. Okay, and the question we can now answer, because we can solve a log equation, is at what age has a boy attained 85% of his adult height? Okay, so we're given a percentage of 85%, and we're asked to solve for the age, which is represented by x. So here we have a log equation with x inside the log, and there are terms that are not associated with the log. So our strategy will be to get the log alone and then use the definition of the log. So first thing, subtract 29 on both sides of the equation. 85 minus 29 is 56. Okay, and then we'll want to divide both sides of the equation by 48.8. Okay, so in order to eliminate too much rounding, let's leave this as a fraction for now. 56 over 48.8 equals the log of x plus 1. Now that this log is alone, I can use the definition of the log. Remember that if there's no base, the base is implied to be 10. So we'll have 10 to the 56 over 48.8 power equaling x plus 1. And then solve for x by subtracting 1. Okay, so on our calculator, how this would look if you have just the classic print, not the math print, we'd have 10 raised to the, in parentheses, very important you put this in parentheses, 56 divided by 48.8, close your parentheses, and subtract 1. So we get 13.05 years old. So at about age 13, a boy is 85% of his adult height.